Welcome to Physics Can Be Fun with me, Stephen Thomas. I'm continuing with organic chemistry, and we're talking about the unsaturated hydrocarbons, namely the alkenes and the alkynes. Now, the alkenes are carbons with double bonds attached to other carbons. So that's what we call unsaturated when we don't have, when we have double bonds or triple bonds. So if we just have single bonds, such as those, then they are saturated. But when we come with double bonds, which we have in the alkenes, we have double bonds. And with the alkynes, we have triple bonds between the carbons. So that is the difference between the alkenes and the alkynes. The alkenes, their name always ends in "ene", and the alkynes, the name always ends in "-ine". So let's have a look first of all at the alkenes. So let's, for example, choose a very simple one. Something like that. And let's get another one. And let's put a hydrogen there and a hydrogen there. So what do we notice? We have an unsaturated or double bond between two carbons. And then we have our hydrogen on either end. So how would we name that? Well, it's got meth, eth. Its prefix would be eth, and then it's got a double bond, so we would call it ene. The alkenes end in ene. So it's a two carbon, that gives it the eth, and then because it's got a double bond, eth-ene. We could say eth-1-ene to show that our double bond is on the first carbon. Doesn't actually matter whether we number it from this side or this side, that would still be the first carbon that our double bond is on. So that would be eth-1-ene. And if we were to add a few more to the chain, let's do this, add that. What would the name of that be? So here we've got, and let's add a hydrogen there and a hydrogen on this end. How many carbons have we got? We have got 1, 2, 3, 4 carbons. So it's going to be meth, eth, prop, bute, butene. And it's going to be bute dash, what carbon is it on? 1-ene. Bute-1-ene. Do you see that? We always number from the side, the chain where the double bond is closest. So we wouldn't start numbering from here. The double bond is closer to this side, so therefore we number this as carbon 1. So it's bute-1-ene. And we could, if we added a few more, we could get oct-1-ene. Or if we were to say, move the double bond, let's put it there. How would we number and name this? And let's see if we can end that off nicely as well. Right, how would we name that particular? We see that's an alkene. There's its functional group. So it belongs to the alkenes. That's what we call the homologous series with double bond. Okay, let's count the number of carbons. 1, 2, 3, 4, 5, 6 carbons. So 6 is going to be hex. Dash. Now what carbon is the double bond on? We could count 1, 2, 3, 4, and this is carbon number 4. We could count 1, 2. Which is smaller? 2 is smaller than 4. So we're going to say on carbon number 2 is our double bond, hex 2-ene. And there we go. That's how we name the alkenes. The general formula for the alkenes would be CnH2n. That's the general formula. If we were to look at this one, for example, how many carbons? 1, 2, 3, 4, 5, 6. N stands for the number of carbons, so it would be C6H2n H12. And is that correct? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen. So there's our general formula. And the functional group is a double bond between the carbons. Now, let's go to the alkynes. Let's do them together here. I'm going to simply change this, substitute that for that, and this for this. So now we are looking at the alkynes. Triple bonded, they're also unsaturated. Remember, unsaturated means that not just single bonds, we have double or triple bonds. The alkynes have 3 bonds. So what would be the name of the substance? Well, let's count. 1, 2, 3, 4, 5, still 6 carbons. So it's going to be hex. Now, on which carbon is the triple bond? It's number 2, hex 2, ine. Hex 2, ine. So instead of ene, it's ine. And if we were to, for example, move this one along, what would now the name be? 1, 2, 3, 4, 5, 6, 7 carbons. So 7, what's the prefix for anything with 7? It's going to be het. H-E-P, het. Now, what carbon is the triple bond on? 1, 2, 3, 3, ine. Het 3, ine. Notice each carbon still got 4 bonds, 4 bonds. Everything still balances perfectly. The hydrogens has got 1 bond. All the carbons have got 4 bonds. And so that is the nomenclature for the alkynes, very similar to the alkenes. And notice that we've just dropped another hydrogen in turning an alkene into an alkyne. So whereas that was the formula for the alkenes, have this formula, the alkynes have 2 less hydrogens. So their formula is going to be CnH2n minus 2. So for example, 1, 2, 3, 4, 5, 6, 7 carbons. We're going to have C7H, 2 7s are 14, minus 2 is going to be H12. Let's see if that's correct. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. So that is the general, that gives us the formula for calculating the number of carbons and hydrogens. And the functional group for an alkyne is the C triple bond C. That's the functional group for the alkenes. That's the functional group for the alkynes. Having double or triple bonds makes it unsaturated. And just as a matter of interest, we can tell a saturated from an unsaturated solution by adding brown bromine water. When you add it to an unsaturated solution like this, the solution, which is colorless to start off with, just remains colorless. The double bonds break and they absorb the bromine, but the solution remains colorless. Whereas if you add bromine water to a saturated solution, you find that it turns the solution the color of the bromine, because there's no double bonds which can break to absorb the bromine. So the solution turns brown. So a saturated solution, which is colorless at first, will turn it'll turn brown due to the bromine, whereas an unsaturated solution, these alkenes and alkynes, they remain the colorless liquids, and that is the test for them. These alkenes and alkynes, they all burn very well.